looking at exercise 7D, the laws for logarithms. We're going to learn how to add, subtract, and do powers of logs. Okay? So, before we continue, we did look at these in My Maths Online, but we never wrote them down. So, what does log to the base a of 1 equal? Don't we say a to the power of something is 1? Isn't that how we try and work it out? So what is that something? A to the 0. Sorry, is 1. So log to the base a of 1 is 0. Now, if you grab your calculator, so that a could be anything. It could be log to the base, so that could be log, so examples, log to the base 10 of 1 is 0. Log, so if you grab your calculator and press log of 1, I want you to get your calculator and press log of 1. Remember, log to the base 10, you get 0. But I haven't taught you about log to the base e, but because you don't know what e is yet, okay, it's Euler's number. But log to the base e of 1 is also 0. But on your calculator, the log to the base e number, so that people don't get confused, you've got log to the base 10 is log button, log to the base e is ln button. So if you go to your calculator as well and press ln 1, what do you get? 0. Okay? So the log, it doesn't matter what the base is. So log of 1, whether it be log to the base 10 of 1, ln 1, log to the base e of 1, log to the base 7 of 1, log to the base anything of 1 is 0. Now the next one. Isn't this saying a to the power of something is a? What do you think it is? Yeah, I know that a to the power of 1 is a. So the answer to this is 1. Now an example might be that log to the base 7 of 7. What does that equal? 1, because 7 to the power of 1 is 7. You get it? So if you see log to the base 7 of 7, log to the base 2 of 2, that's 1. Log to the same base and that number there, if they're the same, you get 1. Because we're saying a to the power of what is a? A could be any number. So in these cases, a is any positive whole number. Okay? Or, yeah. Now this one, a, aren't we saying a to the power of something is root a? Yeah, it's a half. You okay with that? A to the power of what is square root of a? It's a to the power of a half. So log to the base a of the square root of a is a half. See if you can work out what the next one is. We're saying that a to the power of something is 1 on a. What's this something? Yeah. So log to the base a of 1 on a is -1. Now, look, the ones you really need to know are the first two. Okay, they've got to be like recall. Okay, this one, a to the power of something is 1 on x. One sec. Learnt this one yet? You haven't learnt this one. But I'll just do it now, but we're doing it later today. Isn't that the same as saying, right, ladies, log to the base a of 1 on x, isn't that the same as log to the base a of x to the -1? Yes? I haven't learnt this rule, but you will very shortly. When you've got log to the base a of a number, this power comes to the front. So it's -1 times log to the base a of x, or negative log to the base a of x. Don't worry about that yet, because we're doing it later. Okay, so if you ever see this, so for example, log to the base a of 1 on x is negative log to the base a of x, but we're going to be spending, 15 minutes on it later. It's just a rule. We're going to derive it. All right? Now, our next box has got two very, very important rules, okay? So because the functions y equals a to the power of x and y equals log to the base a of x are inverse functions, we can say that, now be careful here, that log to the base a of a, you know how you know that log to the base a of a is 1? Right? We can say that log to the base a of the power of x equals just x. So the way I look at it is, you know that log to the base a of a is 1. And if you cross that out, you're just left with x. But we are going to learn a bit later that this x actually comes to the front. So it'll be x times log to the base a of a, which is 1. So if you ever see this, log to the base a of a, so that could be log to the base 2 of 2 to the power of x. That just equals x. So you'll look at it and see log to the base a of a just cancels. It goes. All right? You know how you know that log to the base a of a is 1. All right? So this is just a rule. The other rule is, see how you've got log to the base a of a, then to the power of x? The reason is, I'll just show you. Log to the base a of x is, remember, if you've got this power, we're going to learn about it soon. You bring the x to the front. It's x times log to the base a of a. What's log to the base a of a? 1. So that's just x times 1, which is x. Okay, don't worry, we're going to be doing a whole heap of it. All right? And this, a to the log base a of x, a to the log to the base a of x, a log to the base a also cancels. And that eliminates, and you're just left with x. Okay, so they're just two rules. So, examples, simplify the following. Log to the base 7 of 7 to the power of 12. So, can you see that properly? With this power, I can bring it to the front. It is 12 times log to the base 7 of 7. I know I haven't shown you that rule yet. So when you've got log to the base something of something and another power, the power comes to the front. Okay? But, or you can just say, I know that just wipes out. And what are you left with? If log to the base 7 of 7, it wipes out. You're just left with 12. But really, the power comes to the front, so that is 12 times log to the base 7 of 7, which is 12 times 1, which is 12. Another one, 5 log to the base 5 of 11. The 5 log to the base 5 goes. And what are you left with? Just using that rule up here. Anyone? No, 5 to the log. No, that goes. You're just left with 11. Okay? So you need to know. 1, 2, these. Log of 1 is 0. Very, very important, this one. So that could be log to the base 10 of 1. ln, log to the base e of 1. Log to the base anything of 1 is 0. The other really important result is log to the base a of a is 1. You can try that because we can do log 10 on your calculator. Log to the base 10's on your calculator. If you press the button log 10 on your calc, it's doing log to the base 10 of 10. Because log does log to the base 10 on your calc. So do log 10 on your calc. Tell me what you get. You should get 1. I want you to do it, but don't believe me. Do it. All right, log 10 means log to the base 10 of 10 is 1. All right? Now, the other things that you need to know or recall is if you see something like this, log to the base a of a to the power of x, what you'll do, you'll just say to yourself, oh, these, log to the base a and the a cancel out and I'm just left with x. That's what you say to yourself. Here, a. Now, this is the other way around. Instead of log to the base a being first, it's a to the power of log to the base a. You say they're inverse operations of each other. They just cancel out. So I'm just left with x. Okay? So if you see log to the base 7 of 7, they're inverse operations. That all cancels. You're just left with 12. If you see 5 to the power of log to the base 5, they are inverse operations. They just cancel each other out. You're left with 11. All right? These laws are extremely important as well. So there are 3 laws for logs that we are going to look at. And the first one is the following. The log of a product is the sum of the logs. That is because it's written like this. Log to the base A of x times y. That is the log of the product. Equals log to the base A of x plus log to the base A of y. Now, if the product is the sum of the logs, what do you think the log of a quotient? Now, quotient means to divide. Yeah, it's the difference of the logs. So, the log of a product is the sum of the logs. That's our first rule. Very, very important. Log to the base A of x times y equals log, as long as the bases are the same. Log to the base A is log to the base A of x plus log to the base A of y. The next one, the log of a quotient is the difference of the logs. So that rule is log to the base A of x divided by y is log to the base A of x minus log to the base A of y. That's the second rule. And the last one I sort of showed you before, but I didn't formalize it as a rule. As for logs, the first one, log to the base A of a product is the sum of the 2 individual logs. Log to the base A of a quotient, so log to the base A of x divided by y is log to the base A of x minus log to the base A of y. It's the difference of the logs. You know, doesn't it make sense? Times and plus goes together, and divide and minus goes together if you were thinking about operations. Divide makes things smaller, generally, unless you're dividing by a fraction. Subtraction makes things smaller. Multiplication makes things bigger if we're talking about whole numbers. Addition makes things bigger if you're talking about positive numbers. The last one is, I sort of mentioned it up there, log to the base A of x of a power is when you bring that power down to the ground. So log to the base A of x, so the log of a power is the multiple of the log. That's when we bring the n, the power down, n times log to the base A of x. Now we're going to practice these. Really, really important. So the log to the base A of x to the power, this power has to come down to the front. N times log to the base A of x. So just some questions from your textbook. Question 12. No, question 2. Question 2. Use the log laws to simplify. Now we're going to practice those. Here we go. This is question 2b. Log to the base 15 of 3, plus log to the base 15 of 5 equals. Now, anyone? I'll write the first log law that we're referring to. Log to the base A of x times y is log to the base A of x plus log to the base A of y. That's the rule that would be used here. I've given you the right-hand side here. So it's, yes, it's log to the base 15 of 3 times 5. So, girls, the addition of 2, so it's the addition of 2 logs is equal to the product of those 2 logs, but the base has to be the same. So that's log to the base 15 of 15, which is, you know, is 1. Okay, the next question, E. Log to the base 10 of 50 plus log to the base 10 of 20. Okay, bases are the same, good. We apply this log law. It's log to the base 10 of what? What do I do with those 2 numbers? I multiply them. 50 times 20, which is log to the base 10 of 1,000. Now we think back about what we were doing before. Doesn't that mean 10 to the power of what is 1,000? And the answer is 3. Now this one, can you put this one in on your calc? It's log to the base 10. You can. How do you do this on your calc? You just press log of 1,000 and you'll get 3. But remember, it means 10 to the power of what is 1,000. Question 3. Use the log laws again to simplify the following. 3b. Log to the base 4 of 20 minus log to the base 4 of 5. What log law will I use now? It's the one with subtracting, which is the quotient rule. So the rule is log to the base a of x over y is log to the base a of x minus log to the base a of y. That's in that format. What do I do with the numbers? I divide them. So it's log to the base 4 of 20 divided by 5. What's 20 divided by 5? It's 4. And what's log to the base 4 of 4? 1. That's that rule. Log to the base a of a is 1. So look at all these rules that we're using, because we know that 4 to the power of 1 is 4. Or you remember the rule, log to the base a of a is 1. Question E. Log to the base 3 of 81 minus log to the base 3 of 10. Keep going. Okay, what do we do here? Log to the base 3 of, what do I do? Oh, that's 810, sorry. 810, mistake. Can you fix it? Log to the base 3 of 810 minus log to the base 3 of 10. What do I do with the numbers? I do 810 divided by 10, which is log to the base 3 of 81. Sorry, there was a mistake in the question. Power of what? Because 3 is the base. 3 to the power of what is 81? 3 to the power of 4 is 81. Next, this one is a combination of addition and subtraction. So you can use the laws one at a time if you want. Let's just do the first two. Isn't that log to the base 5 of 12 plus log to the base 5 of 2? What do you do with the 12 and the 2? You multiply them. Oh, interesting, this one. So you've got log to the base 5 of 24 minus log to the base 5 of 24. You actually don't even need to use log laws for that, but you can if you want. What's something minus itself? 0, but let's do it with log laws. Something take away itself is 0. But let's do it with log laws. How do you do this with log laws? What do you do with the 24 and the 24? You put them over each other. When you are subtracting logs, that's like dividing. What do you get there? Log to the base 5 of? What's 24 over 24? 1. And what's that other rule? Log to the base a of 1 is 0. It's because 5 to the power of what is 1, girls? 5, it's because 5 to the 0 is 1. So the answer to this is 0. Now, instead of doing all of this, we should have recognized that it's 0 from this line. Something, take away itself is 0. You don't have to do all this fancy stuff. Do you get it? But if you do want to, you can use the log laws. But you say to yourself, you could do this many ways. You could remember the rule, or I just think 5, if you know the basic law, just think where we started today, that we say 5 to the power of what is 1? It's 5 to the power of 0 is 1. So it's 0, but much easier to do it from up here. Another combined question, 4H. Log to the base 2 of 12 plus log to the base 2 of a third. Okay. Let's do this one. All right, we're adding. What does that mean? Log to the base 2 of, what are you going to do with the 12 and the third? What's the rule? Multiply them. So what you've got to do with logs, the way you do logs is you know the rules and you say that's that rule and you follow the rules religiously. That is how you can do any difficult question in logs. If you just follow the rules, you'll be all right. Okay? So what do you do with the 12? What do you get here? 4. And doesn't this mean 2 to the power of what is 4? Which is 2. But later, you can do that on your calculator. I showed you before. We're going to do change of base next lesson. All right, question 5. Question 5. So use the log law, this one. Log to the base a of x to the power of n equals n. Remember, that's when you bring the power down. N times log to the base a of x. To write each expression in terms of log to the base a of 2. So the other type of thing that you're going to see where you've got to multiply or add. The multiplying goes with the adding. The division goes with the subtraction. The power one, you bring the power to the front. Okay, so just a few questions here. Log to the base a of 16. It's saying use this log law to write each expression in terms of log to the base a of 2. Now, I don't have log to the base a of 2, but tell me what 16 is. 2 to the power of what? 4. Now, what do I do with that 4? I bring it to the front, bring it down. Log to the base a of 2 is normal. And then it's got a power. That power comes to the front. Now that is the most simplified form of that log. We'll just do a few more. Log to the base a of 64. Log to the base a of 1 over 32. And log to the base a of root 2. We're just doing those ones. So that's log to the base a of, now 64 is 2 to the power of, oh no, that 2 to the power of 5 is 32. It must be 2 to the power of 6. You can just check on your calc. 2 to the power of 6. So what do I do with the 6? It comes to the front. The power 6 times log to the base a of 2. How am I going to do the next one? Log to the base a of 32. 32 is 2 to the power of 5. But I don't want to write it like that. I don't want 1 over. How can I write this 1 over? 2 to the negative 5. What is the rule? Now I've got a clear power. The power comes to the front. So that's negative 5 log to the base a of 2. Are we good? This is an extremely important law, this one. And this last one, log to the base a of square root of 2. I can't write it. I need to write what square root is. What's square root? What power is square root? 2 to the half. What is the log law? That half, the power comes to the front. So it's a half times log to the base a of 2.